Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the first question from the mid-year examination which was written in the province of Eastern Cape. This question guys just consists of multiple choice questions. I'll just pick the correct answer from the given options. And please guys, do expect a total number of 7 videos since the question paper had 7 questions in total. And secondly guys, please do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay. I'm supposed to choose the correct option given below, guys. Okay. The homologous series that contains a carbon-to-carbon triple bond is called an alkyne. A carbon-to-carbon triple bond is called an alkyne. Alkanes have single bonds between adjacent carbons, and then alkenes have at least one double bond between adjacent carbons, and then haloalkanes have single bonds between carbons and well as at least one halogen. Are you together? The only compound that has triple bonds between carbon to carbon is an alkyne. Okay, and then now you're supposed to consider the following compounds. Compound A is pentane 1-ol, compound B butane 1-ol, compound C is propanoic acid. Which one of the following correctly rank the above pure substances in order of increasing strength of intermolecular forces? Okay. Propanoic acid, guys, will have the strongest intermolecular forces compared to butane 1-ol and pentane 1-ol. Why is that the case? Yes, all of these three have a hydrogen bond, which is a stronger intermolecular force. Are you together? However, pentanoic acid is a carboxylic acid, and carboxylic acid, guys, has 2 sides of hydrogen bonds. That's why propanoic acid will be the strongest. Are you together? Okay, and then now let's rank between butane 1-ol and pentane 1-ol. We are dealing with primary alcohols. The only difference is the chain length. Are you together? So pentane 1-ol has a greater surface area compared to butane 1-ol. So if ever, guys, we group them from the one with the lowest boiling point to the one with the highest boiling point, we'll start with butane 1-ol, pentane 1-ol, and then propanoic acid. The only option that lists them in that order is option D rather. Consider the structural formula of this functional group over there. Which one of the following compounds contain the above functional group? The double bond O with an H, guys, at the terminal carbon is only available on aldehydes. I know that yes, you do have carbonyl with ketones, but there must be other 2 carbons bonded with the functional group. Are you together? Once there is an H, that means this functional group of ours is at the terminal, and the name of this functional group is a formyl ion or formyl group that only exists on aldehydes. Are you together? And compound A is an aldehyde. Why? Because of its suffix. The suffix is al. The suffix for aldehydes, guys, is always al. Are you together? This one, O is for ketones. This is for alcohols. This is for carboxylic acid. This is the only aldehyde we have. Now let's go to 1.4. 1.4, we are told that 2-methyl-propane 1-ol can form 2 isomers. Which one of the following combination correctly identifies the isomer and the type of isomer? Okay. Yes, butane 1-ol is an isomer, but it's not a positional isomer. Are you together? It's a chain isomer. So this one, let's mark it incorrect. And then you have 2-methyl-propane 2-ol. Yes, this is an isomer, but it's not a chain isomer. It's a positional isomer. So let's mark it incorrect as well. And then we have butane 1-ol. Butane 1-ol is an isomer, guys, but it's not a functional isomer. It's a chain isomer. So the correct answer will be D, because 2-methylpropane 2-ol is a positional isomer. They just shifted the functional group from the terminal carbon to carbon number 2 over here. So this is the correct answer. The conversion of this compound over here, we have an alkene, we have CH3, we have CH and CH2. That means there's a double bond over there, né? And then the other compound which is formed, it has CH3, CH2 and CH3. Firstly, the double bond was broken down and then 2 hydrogens were added over there. Are you together? So this type of conversion is an addition reaction, number 1. And the type of addition reaction, it's hydrogenation, since you are adding 2 hydrogens. Are you together? So this is hydrogenation. Where do I see hydrogenation over here? Hydrogenation, that's B. That's B. Okay. A hydrochloric acid reacts with excess zinc according to the balance equation. Okay, we are given the reaction there, and then we are being asked which one of the following factors will influence the yield of hydrogen but not the rate of production of hydrogen. Okay. I want to find the factor that will influence the yield of hydrogen but not the rate of formation of hydrogen. Eh? Whatever factor, guys, it shouldn't be a factor that affects the rate of reaction. So in this case, temperature will be out, the state of division will be out, concentration will be out. The only correct answer is B. Are you together? Because volume, number 1, if ever, guys, I pour more volume of hydrochloric acid, yes, I will end up forming more hydrogen gas. Are you together? But if volume is not a factor that influences the reaction rate, so this is the only correct answer we have over there. And then for 1.7, we are told that carbonic acid ionizes in water in 2 steps. It's a diprotic acid. That's what they are telling us. Né? The first step of the ionization is given by the equation below. Which one of the following substances in the above reaction can act as ampholites? Ampholites, guys, are substances which can either accept a proton or donate a proton. Are you together? They are sometimes called amphiprotic. Are you together? They can act as a base or as an acid at the same time. Are you together? If you check our forward reaction, this guy over here will receive a proton and then will end up having H3O plus. But if you check the reverse reaction, this guy over here will donate a proton because it was H3O plus, and then on the reverse reaction it became H2O. So water can either receive or donate a proton. Number 1, are you together? And then secondly, so if guys, water can donate or receive a proton, so water is one of the ampholites. So this one does not have water, so this one is incorrect, and also this one is incorrect because they don't have water. Secondly, if we check our carbonic ion, if you focus on the forward reaction, are you together, guys? This guy over here can either gain a proton to become carbonic acid or lose a proton so that it can form these ions over here. Are you together? So we have 2 ampholites over there, guys. Né? This is the first ampholite, the second one is water. So the correct answer over there is C. A is incorrect. This is an acid. It's carbonic acid. It's not an ampholite. Okay, now let's go to 1.8. The potential energy diagram for the following reversible hypothetical reaction is given below. Okay, we are given the potential energy in kilojoules per mole and then the reaction coordinates on the x-axis. Consider the following statements regarding the diagram. Okay. The enthalpy or the change in enthalpy for the forward reaction is positive. If guys we can check, position Q just shows us the heat of the products. Position P is the heat of reactants. So if you find our enthalpy, we'll take a positive number, or rather a bigger value, subtract it to a smaller value, and we'll end up having an enthalpy which is positive. Are you together? So the enthalpy for the forward reaction is positive. That means the enthalpy for the reverse reaction has to be negative. Are you together? Okay, and then so this one is correct. Let's check the second Roman figure. Catalyst will lower PQ. No, catalyst guys will never lower the enthalpy, but the catalyst will simply lower the activation energy. We'll have a lower activated complex. Position R would be here if a catalyst was used. So this one is incorrect. Okay, and then now we are told that the reversible reaction is exothermic. Yes, that's true, guys. Since the enthalpy for the forward reaction is positive, that means the forward reaction is endothermic. And if the forward reaction is endothermic, this simply means that the reverse reaction is exothermic. Are you together? So the correct answer is the answer that has a combination of both, option 1 and 3. So that's just C. Okay, consider the following reversible reaction at equilibrium in a container. I have carbon and carbon dioxide. They will give me carbon monoxide. The following, or rather the volume inside the container is decreased while the temperature remains constant. Whenever guys we decrease the volume, we are increasing the pressure, and an increase in pressure will always favor the side with the least number of gas moles. Are you together? Over here I only have one gas. How do I count my gases, guys? I check the stoichiometric coefficients of my gases. Since the coefficient is 1 over there and I have 2 over here, that means this reaction of mine will favor the reversible reaction. Number 1. Are you together? Will favor the reverse reaction. So if I favor my reverse reaction, guys, it simply means that I will use up my carbon monoxide to form more carbon dioxide. Are we together? This one is not affected by equilibrium, so this will just remain the same. I'll just use my carbon monoxide to form more of my carbon dioxide. Are you together? So the amount of carbon dioxide will be lower. Are you together? So so these ones are just incorrect because they are telling us that carbon monoxide will be higher, and that's incorrect. Now let's talk about the rate of reaction. When guys we increase the pressure, the rate of reaction will also increase. So the correct answer will be A. This one is incorrect because it says the reaction rates will decrease. That's not true, guys. If we increase if ever we increase pressure influences the rate of reaction. If we increase pressure, the rate of reaction will increase. Are you together? Yes, equilibrium will shift, but the rate of reaction will increase, guys. Please keep that in mind. Okay. And then now we are told to consider two solutions of barium hydroxide and potassium hydroxide, each with a concentration of 0.1 moles per cubic decimeter. Consider the following statements. Both potassium hydroxide and barium hydroxide can be regarded as Arrhenius bases. Yes, they can. Okay, so this one is correct. And then barium hydroxide will produce a higher concentration of hydroxide ions than potassium hydroxide when they dissociate. This is true, guys. Why is that the case? Because our barium hydroxide whenever it dissociates, it will give us barium ions plus 2 hydroxide ions. Are you together? But for potassium hydroxide, we'll simply have K plus as well as OH minus. Are you together, guys? So if the concentration of our barium hydroxide is 0.1 mole per cubic decimeter, since the ratio of barium hydroxide and the hydroxide ion is 1:2, that means we'll produce 2 times the concentration over there. Are you together? But for potassium, the same amount of concentration of our potassium hydroxide would be the same amount of concentration of the hydroxide ions. Are you together? So the first two are correct, and then now we are told that double amount of hydrochloric acid is needed to neutralize potassium hydroxide than barium hydroxide. This is incorrect, guys. Ne? This is incorrect. Why is it incorrect? Because hydrochloric acid produces 1 proton. Are we together? And for us to neutralize this guy over here, we will need 2 protons as well. So the correct answer, guys, is the one that contains option number 1 and 2. So that's just option B. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you very much.